I realize there's one more question over here. I think you can do it as your own practice. So self-practice. Okay, I will not be going through this part. Right now, next part we're going to talk about is oxidizing and reducing agents. So what is an oxidizing agent? In this case here, oxidizing agent is a substance, okay, that causes another substance to be oxidized. So in this case here, we call it an oxidizing agent because it oxidizes things. So example of oxidizing agent is maybe Br2, Cl2, okay, we have KMnO4, we have K2Cr2O7. Okay, this is actually bromine. Okay, the bromine element. This is actually your chlorine. KMnO4 is known as your potassium manganate 7. Okay, so please take note of this name. You'll see it quite often. Another one is K2Cr2O7. This is known as potassium dichromate 6. Okay, this actually has been taken away out of your QA syllabus because apparently it is quite toxic. Okay, it causes cancer and stuff like this. But this is still something interesting to know. Okay, because it's an orange color substance. So this is your oxidizing agent. So now, obviously, what is a reducing agent? Is opposite of this. So it is a substance that causes another substance to be reduced. Okay, so what are some of the examples? Some examples are, we have H2. Another one that we have is your metals, such as lithium, potassium, calcium. Okay, some of or more other metals. We also have Ki. We also have SO2. So now, these are some examples of a reducing agent. What is their name? H2 is actually your hydrogen. Okay, hydrogen. Metals, obviously, you don't need to explain too much about itself. Okay, let me rewrite this a bit ugly. Hydrogen. Okay, Ki is actually your potassium iodide. Okay, SO2 is actually your sulfur dioxide. Now, so after knowing some of this, let's look at identifying our oxidizing and reducing agent. So interestingly, okay, if you have seen our thing before that, examples of oxidizing agent, ta-da, Cl2. So this is an oxidizing agent. Okay. Interestingly, you cannot have the oxidizing agent alone. For a redox reaction to occur, you need an oxidizing agent and a reducing agent. So if Cl2 is the oxidizing agent, then which must be the reducing agent? The answer is, ta-da! This guy here is the reducing agent. These two agents work in pair. One must be oxidizing, the other one must be reducing in order for it to be known as a redox reaction. Okay, this is one way. It's just by looking at the examples and memorizing them. What if we do not do so? What if we don't memorize? How do we know what is the oxidizing and reducing agent? So let's look at this case here. What you can do is look at the oxidation state. So hydrogen initially, element on its own, oxidation state 0. Oxygen element on its own, 0. Now water, H2O, hydrogen now is in a compound, so oxidation state +1. Oxidation state of oxygen is a -2. So hydrogen changed from a 0 to a +1. So it undergo oxidation. They undergo oxidation. On the other hand, oxygen became a -2, so it has undergone reduction. Okay? Now, this is where it becomes a bit mind-boggling. Okay, what we know is that H2 is oxidized to H2O. So if H2 is oxidized, I say again, if H2 is oxidized, so therefore, okay, H2 is oxidized, therefore this is a reducing agent. Okay, if H2 is oxidized, that means it is a reducing agent. I'll explain to you why later on. Let's look at the second one. We know that O2 is reduced to H2O. Okay, so we know that for O2 it is reduced, so therefore this guy here must be an oxidizing agent. Okay, now let me show you something. H2 reacts with O2, correct? So how is H2 oxidized? Think about it. H2 is oxidized by something, but what oxidizes it? H2 is mixed with O2. So the oxygen must have oxidized H2 in order for it to be oxidized. So that's why O2 is the oxidizing agent. It oxidizes H2. Now, you say that O2 is reduced, so something must have reduced it. Looking at our equation here, there's only one thing that can reduce my oxygen, which is hydrogen. So therefore, H2 reduced by oxygen. So normally in this case here, if something is oxidized, it is actually the reducing agent. When something is reduced, it is normally the oxidizing agent. This is how it works. It's always like opposite. You must figure out the starting point of how to go about doing it, which is knowing whether it's oxidized or reduced. Okay, let's look at the next part. Zinc, zinc sulfate, copper sulfate to copper. Okay, let's look at determine the oxidation state first. Zinc, initial oxidation state 0. Okay, for copper sulfate, the copper here actually has oxidation state of +2. Okay, how do you know? Because if you do your crisscross, you realize Cu 2 plus and SO4 2 minus. Okay, when you do your crisscross, you realize you form the formula Cu2 SO4 bracket 2. Simplify it, you get Cu SO4. So your copper actually has oxidation state of +2. Sulfate, okay, this one is an interesting one because you know it's SO4 2 minus, but you don't know what's the oxidation state of sulfur. So let's try it out. SO4 2 minus, sulfur I don't know, so I put it as X. How many X do I have? 1. Oxygen, oxidation state is actually a -2. How many oxygen do I have? 4. So 1x plus 4 times 2 minus equals to overall charge -2. Do your maths, x equals to +6. So in this case here, sulfur is a +6. Oxygen once again is a -2. Now come to this point here, I know that sulfur is a +6. Oxygen is a -2. So you do your simple maths again, you realize zinc is having a charge of +2. Copper here element on its own, so it's a 0. So sulfur, no change. Oxygen, no change. So we just leave it, okay? Boring stuff. We don't really care about it. Now, what you realize is that there's a change here. Zinc from 0, it has become a +2. So we know that Zn is, Zn is oxidized to what? Zn is oxidized to ZnSO4. Okay, we also know that copper from +2 to 0, so this is actually reduced because it's a decrease in oxidation state. So we know that CuSO4 is reduced to Cu. So in this case here, I will know that if this zinc is oxidized, that means it must be the reducing agent. Okay, this guy here must be the reducing agent. If copper sulfate is reduced, okay, if this guy here is reduced, it must be, okay, let's use blue. It must be the oxidizing agent. So this is how we can identify it. So this marks the end of your redox. Okay, you can look for the teacher for more examples and stuff like this. But generally, knowing how to use the oxidation state is very important. Make sure you know how to do it. Okay, oxidation states. This one is important, must know. So just take note, this marks the end of my last part.